Hello and welcome to Mindrest Stories. This evening, we gently venture into the tranquil expanses of the tropical woodlands. These areas teem with such vibrant existence that they seem like wholly distinct realms apart from our everyday surroundings. They serve as the planet's vital respiratory system, exhaling vapors that form clouds high above. At dusk, they radiate a subtle luminescence from concealed wildlife, buzzing with activity and enigma from all sides. The atmosphere itself holds enigmas that researchers are gradually unraveling. As you relax, allow your imagination to roam amid soaring trunks ascending into swirling fog, streams meandering across dim hollows, and flora preserving echoes of eras much more ancient than our familiar terrains. Tropical woodlands transcend mere dwellings. They function as dynamic mechanisms influencing climate, enriching the terrain, and safeguarding life forms that people might not have conceived yet. If these serene explorations appeal to you, feel free to hit like, subscribe, or drop a comment in the section below. It assists fellow viewers in discovering this space, one peaceful wanderer after another. For the moment, inhale deeply. Permit your frame to unwind. Let your ideas become leisurely and tender as we tread softly into the verdant twilight of the vibrant biosphere. Let's commence. In these woodlands, foliage exists expansive enough to cover a whole youngster. Various flora develop such colossal fronds that they appear crafted for titans. Wide and sleek, they extend outward resembling organic canopies capturing descending precipitation and rays. During tempests, liquid pours from their broad exteriors in consistent flows. In milder conditions, they establish arid refuges under their cover. Such massive foliage typically emerges on vegetation near the woodland base. Since illumination is scarce there, every frond enlarges to seize maximum possible. Creatures employ them as stages, cradles, or barriers. Amphibians deposit spawn in the reservoirs accumulating on their tops. Bugs conceal along their veins. Even diminutive furry animals might repose beneath their safeguard. Notwithstanding their magnitude, the foliage stays fragile, modifying their tilt to discard liquid or lessen gust impact. Their exteriors frequently display designs disclosing how sustenance journeys via the vegetation. To meet one is to sense the magnitude of woodland expansion, where the natural world fashions items both enormous and elaborate with identical precision. Certain arboreal species flower solely every several decades in flawless harmony. Over extensive woodland areas, multitudes of arboreal entities can erupt into blossom simultaneously. Although numerous years could have elapsed since their prior exhibition, each waits in hushed preparedness, detecting faint indicators in warmth, downpour, and radiance. Upon the instant's arrival, the overhead layer morphs into an ocean of petals, perfuming the breeze and drawing swarms of fertilizing agents. This infrequent alignment overwhelms fauna that could consume the blossoms or kernels, guaranteeing sufficient endure to perpetuate forthcoming lineages. For a short span, the woodland turns into a carnival of hues visible from aloft as a vast surge of luminosity. Fauna relocate toward the flowering areas, ingesting nectar that manifests merely once per lifespan for particular kinds. Subsequently, the petals descend resembling mild drizzle, blanketing the woodland base. The arboreal entities then resume serene anticipation, tallying unspoken years till the subsequent collective arousal. Woodland vegetation interacts via subterranean mycelial webs. Underneath the earth resides a concealed lattice of filaments linking the radicals of innumerable vegetation. These mycelial strands function as muted couriers, transporting alerts from one entity to another. When vegetation perceives peril, it can dispatch compound alerts into this lattice. Adjacent vegetation reacts by fortifying their safeguards prior to the hazard's approach. Sustenance likewise traverses these routes. A robust arboreal might distribute assets with a faltering sprout, aiding its endurance until it amasses adequate illumination. This below-ground interaction fosters a feeling of collaboration that fluctuates continually as surroundings alter. Every linkage pulses with data, interlacing vegetation into a society instead of isolating them to survive independently. The lattice enlarges as radicals extend and shrinks when Earth desiccates. It constructs an ever-evolving chart of existence just beneath the exterior, obscured from sight, yet crucial to the woodland's vitality. Amphibians exist so minuscule they can perch on a fingernail. Amid the woodland underbrush, petite amphibians inhabit crevices that bigger beings overlook. Their forms are no larger than a little finger's end, featherlight sufficient to balance on a solitary dew-drenched frond without curving it. These tiny amphibians slip into moss pockets where dampness accumulates in ideal equilibrium. Each bead turns into a haven, a foraging territory, and occasionally a breeding site. Their tones are astonishingly resonant for their scale, ascending from the debris as shrill summons merging with bug drones. Owing to their tininess, they depend on disguise over velocity. Their epidermis motifs replicate the models of dropped foliage or the textured rind of arboreal bark. Investigators examining them must proceed gradually and heed attentively, since detecting one frequently resembles observing a frond animate. Their being underscores that woodlands are molded not solely by lofty arboreal, but also by beings subtle enough to vanish amid soil particles. Particular woodland fauna illuminate in obscurity. As evening envelops the overhead, luminosities emerge that originate not from the heavens. Specific bugs radiate with tender throbs, shaping floating star clusters below the limbs. Particular mycelia discharge mild verdant auras over toppled timbers. Even several furry animals generate dim flickers that sparkle when agitated. These illuminations stem from compound responses inside their forms that liberate minuscule energy bursts. They employ luminescence to lure companions, caution hunters, or converse with kin. In profound gloom, the illumination turns into a covert dialect inscribed across rind and foliage. Each kind crafts its distinct motif, disclosing itself merely to those adept at interpreting the tender glow. To traverse these woodlands after dark is to sense as if celestial bodies have lowered and dispersed across the animated terrain. Bioluminescence persists as one of the woodland's most captivating enigmas, suggesting concealed mechanisms that persist irrespective of human observation. Particular winged insects consume the saline secretions of chelonians. Beside waterways, winged insects congregate around chelonians basking in warmth. They near warily, hovering near the chelonians' ocular edges. Chelonians frequently expel minor salty fluids, and winged insects depend on these elements to equilibrate their nourishment. The association is benign and has evolved into a subtle interplay between markedly dissimilar beings. The light pressure of the winged insects seldom perturbs the chelonians, who persist in sunning as their guests imbibe the valuable beads. This conduct discloses how assets are exchanged in unanticipated manners inside the woodland. Even an item as minor as a secretion turns into a survival chance. These exchanges emphasize the nuanced mutual reliance among kinds where instances of tranquility and exposure spawn bonds that uphold existence across varied spheres. The woodland conceals arachnids that construct expansive snares. In the faint gaps between limbs, vast snares span open atmosphere like glistening meshes. Their filament strands sparkle with minute beads that accentuate the woven configurations with remarkable durability. These arachnids fashion frameworks broad enough for petite avians to graze while soaring. Although they infrequently ensnare avians, the potential persists since the snares are sturdy and positioned strategically. Bugs constitute their typical quarry, but the snare's dimension affords access to broader food varieties. The arachnids themselves are vivid beings with shades that protrude in diffused illumination. They linger at the snare's core, immobile, detecting oscillations via slender appendages. Each quiver narrates a tale about what has intruded their lure. Despite their scale, these arachnids fulfill vital functions in equilibrating bug numbers and preserving the habitat's well-being. Their attendance recalls that the woodland encompasses wonders both aesthetic and unforeseen. Bradypuses cultivate algae within their pelage and harbor complete microhabitats. The dense pelage of a bradypus shapes furrows that amass dampness, fostering perfect settings for algae proliferation. This verdant hue aids bradypuses in merging with the overhead, rendering them challenging for hunters to discern. Inside their pelage reside not merely algae, but also bugs and mycelia that depend on the microenvironment the bradypus supplies. Particular lepidopterans complete their existence phases inside this mobile dwelling. As bradypuses lower to the terrain for elimination, the lepidopterans deposit over in the earth. Upon hatching, the juveniles ascend back into the pelage, perpetuating the bond that has persisted for epochs. The algae might provide sustenance when bradypuses groom their pelage. Collectively, these exchanges form a diminutive realm that progresses languidly through the limbs. Bradypuses exemplify the woodland's motif of linked existence, illustrating how a solitary being can accommodate a society amid its mild motion. Particular woodlands inundate so profoundly that aquatic vertebrates navigate amid the arboreal. In specific periods, liquid ascends gradually through the woodland until the terrain vanishes under glimmering basins extending for legs. The shafts of lofty arboreal become columns in an immense submerged domain, their radicals concealed beneath serene flows. Aquatic vertebrates glide via these aquatic passages as if traversing a primordial metropolis. They produce plummeting from overhead limbs, gnawing at kernels and tender flesh. Particular kinds synchronize their relocations with the inundations, since the broadening waterways grant entry to fresh foraging zones. Avians modify their pursuit tactics, plunging into the liquid between limbs. Primates observe the altering scenery from elevated roosts, awaiting the liquid's withdrawal. The metamorphosis is so thorough that it is simple to overlook that arid woodland resides below the surface. When the inundation ultimately recedes, it deposits nutrient-laden deposits that nourish the whole habitat. This sequence discloses how adaptable woodland existence can be, adjusting elegantly to the gradual ascent and descent of liquid. The vast river of the Amazon transports more liquid than the subsequent 7 major rivers united. This colossal waterway progresses with a constant vigor that sculpts the encompassing scenery. Its flow is expansive and potent, conveying minerals, kernels, and floating timbers through conduits that interlace across landmasses. Numerous tributaries contribute to the primary river, collecting precipitation amassed from woodlands extending past the skyline. The liquid's quantity is so immense that fresh liquid from the river extends far into the sea, forming a visible plume from elevated above the globe. Inside its depths dwell innumerable aquatic vertebrate kinds, some exclusive to this place. Fluvial cetaceans maneuver its turbid liquids, utilizing nuanced acoustic motifs. Inundated woodlands rely on its elevation and decline, reacting to cadences that have endured for myriad generations. Journeying along its exterior resembles traversing a vital conduit that sustains all it contacts. The river conveys narratives of remote peaks, conveying them onward to the ocean while nourishing the woodland with each swell. Woodlands generate their own precipitation by expelling dampness. Each frond in the woodland liberates minute vapor beads into the atmosphere via a mechanism that converts radiance and retained liquid into haze. When myriad fronds perform this concurrently, the atmosphere above the overhead saturates with dampness. Warm flows elevate the vapor upward until it chills and coalesces into nebulas. Ultimately, these nebulas discharge precipitation that descends back onto the woodland, fulfilling a sequence that hinges on every vegetation from the tallest arboreal to the tiniest bush. This self-generated downpour assists in sustaining the perpetual humidity that woodland existence demands. Fauna depend on this dampness for hydration, cooling, and refuge. Even the earth gains since recurrent downpours cleanse sustenance into strata where radicals can access them. What initiates as a murmur of vapor from a lone frond becomes component of a colossal atmospheric mechanism. Thus, the woodland genuinely respire, exhaling nebulas that revert as vital precipitation. Particular woodland arboreal ascend so elevated they penetrate the nebulas. Far above the woodland base, these towering colossi elevate their summits into strata of haze that never contact the terrain. Their shafts ascend seemingly eternally, bearing whole societies of bryophytes, orchids, bugs, and avians alongside. In the superior elevations, the atmosphere senses distinct, cooler, and bathed with drifting argent nebulas. Beings dwelling in these altitudes might never descend, expending their complete existences in a domain distant above the earth. The colossal vigor of these arboreal derives from profound radicals that secure into primordial soil and broad buttresses that stabilize them through gales. Each shaft documents centuries of varying periods, hushed inundations, and remote electrical discharges. Some of these arboreal were already venerable when initial human tales were narrated. They function as existence pillars, upholding the verdant framework of the woodland and establishing secure conduits for saurians, primates, and breeze-transported kernels. To position beneath one is to perceive the essence of duration itself, extending upward beyond vision. The woodland overhead is a suspended domain with its personal climate. Distant above the woodland base lies an aerial territory where radiance accumulates in aureate layers and temperate gusts drift between foliage that seldom touch the terrain. This animated ceiling is a maze of limbs, creepers, and concealed cavities. Fauna traverse it as effortlessly as others amble along the ground. Up there, dampness amasses in niches that become minuscule fogs. Precipitation can descend within the overhead without ever attaining the earth. Whole tempests might be mitigated into tender showers before they lower. The warmth can ascend and descend autonomously of the domain below, since radiance gathers on broad foliage that heats the atmosphere. Vegetation exploits this singular climate, extending wide summits to seize illumination and direct liquid into storages that nourish beings who never descend the shafts. Investigators portray this area as a hovering metropolis constructed by the natural world, abundant with existence that most individuals will never behold. Every breeze rearranges it. Yet the configuration persists through centuries of transformation. Below the overhead resides a dim, moist territory few beings ever depart. Down under the luminous roof is a shaded domain where the atmosphere stays dense and motionless. Radiance labors to attain the terrain, creating a locale where twilight endures all day. Vegetation develops gradually here, extending patiently toward scarce beams of illumination. Fauna that inhabit this zone have acclimated to near obscurity. Some depend on aroma rather than vision. Others progress soundlessly through humid debris that cloaks the terrain. The earth itself senses animated as bugs, annelids, radicals, and mycelia interweave through it in perpetual motion. Dropped produce decomposes swiftly in the warmth, liberating abundant sustenance that nourishes a whole society of concealed entities. Every stride is cushioned, buffered by centuries of frond descent. To beings residing here, the woodland expanse can seem like a separate world compared to the overhead above. Many never ascend upward since they have become specialists at maneuvering the shadows, flourishing in a locale molded by serenity and profundity. In particular woodlands, arboreal radicals ascend instead of burrow. Rather than delving into the earth, specific arboreal dispatch their radicals upward and outward, clasping the exteriors of shafts and stones like animated grasps. These atypical radicals disperse across rind in fragile lattices that resemble filigree. They assist the arboreal in capturing dampness from haze rather than liquid from the terrain. This approach permits existence to flourish where Earth is sparse or absent entirely. Some radicals creep toward illumination pockets, shaping bridges that link one arboreal to another. Others spiral around their host in coils that bolster the whole structure through tempests. These ascending radicals also furnish dwellings for myriad minuscule entities. Formicids, arachnids, coleopterans, and even petite amphibians discover shelter within the furrows and passages they form. Since they are exposed to the atmosphere, they throb with the woodland's humidity and become conduits for sustenance that traverses the outer epidermis of the arboreal. This notable acclimation illustrates how innovative woodland existence can be when pursuing novel survival methods. Aerial flora establish suspended gardens aloft. Elevated above the terrain, these extraordinary vegetation take root not in earth, but on the limbs of towering arboreal. They exist dangling in atmosphere, seizing dampness from haze and sustenance from floating particulates. Some shape dense cushions that cradle whole societies of bugs and amphibians. Others amass liquid inside innate basins shaped by their foliage. These minor pools become breeding sites for larvae and hydration points for avians. Aerial flora adds strata of texture to the overhead, creating miniature woodlands above the primary woodland. Orchids, bromeliads, and bryophytes interlace into lush aggregations that shimmer when condensation settles on them. They do not injure the arboreal that host them. Instead, they utilize altitude to attain radiance that would never contact the woodland base. Their attendance helps mold the overhead into a vibrant domain filled with existence and hue, resting tenderly on the shoulders of primordial giants. Particular arboreal endure by encircling others from the summit downward. Commencing existence high in the limbs of a host arboreal, these sprouts dispatch radicals downward through vacant atmosphere until they attain the earth farther below. Once secured, the radicals thicken and envelop the shaft that once sustained them. Gradually, patiently, the clasping lattice constricts, restricting the host arboreal's expansion and ultimately encasing it completely. As the original arboreal weakens, the newcomer ascends in vigor, constructing its own shaft and limbs. Over numerous years, the host might vanish entirely, leaving a vacant column where its form once stood. Fauna utilized the ensuing structure as refuge, ascending inside the empty areas created by this metamorphosis. Though striking, this mechanism is not motivated by animosity. It is merely one of many tactics evolved to attain radiance in a crowded woodland where existence vies for every beam. When the loftiest arboreal topple, whole illumination voids erupt into thickets. A solitary fallen colossus can reshape the scenery for decades. When it plummets to the terrain, the overhead opens and radiance floods into a space that has known dimness for generations. Kernels awaiting silently in the earth abruptly awaken. Juvenile vegetation surges upward in a contest toward the fresh brightness. Creepers extend across the open atmosphere. Bushes and saplings cover the terrain in a patchwork of verdant. Fauna converge on the opening since blossoms and produce appear swiftly in the warm illumination. Avians pursue bugs stirred from the earth. Petite furry animals explore the novel pathways created by the fallen shaft. Over time, this illumination void becomes a cradle for the future overhead, filled with rapid-growing forerunners that prepare the path for slower, longer-enduring kinds. Eventually, the void closes again, but the woodland remembers the instant through every arboreal that rises from that brilliant burst of renewal. Panthers have been observed traversing inundated woodlands by swimming. During periodic rains, waterways expand until they overflow into the woodland, obscuring the boundary between terrain and liquid. Panthers maneuver this transforming domain with potent strokes, gliding between shafts that emerge from the inundation like columns. Their sinews undulate beneath spotted pelage as they progress with composed certainty through obscure pools. Unlike many large felines, panthers relish liquid and employ it advantageously when pursuing. They slide noiselessly beneath low limbs, listening for the splash of aquatic vertebrates or the motion of crocodilians. Ascending is effortless for them, so they can transition from swimming to bounding onto a low limb in a single action. Their extremities produce almost no sound when they attain the bank again. These voyages show how adaptable panthers are in an environment that alters dramatically from period to period. Liquid molds their domain, yet they remain elegant and assured in every form of motion the woodland requires. There are avians in the woodland that can replicate nearly any noise they perceive. Deep within the arboreal, some kinds possess exceptional vocal aptitude that permits them to imitate a broad array of sounds. They can reproduce the cadence of dripping liquid, the summons of other avians, or the rustle of limbs swaying in the gust. Some even echo the tones of distant fauna they seldom encounter. Their capability derives from intricate structures that oscillate in fine, controlled layers. Juvenile avians learn through attentive listening, matching pitches with incredible accuracy. Pairing exhibitions become spectacles in which they showcase the full scope of their imitation. These exhibitions lure companions and also indicate territory to competitors. Within their melodies lies a living repository of the woodland's sounds because each generation carries motifs they acquired from prior ones. When they summon, the woodland itself seems to articulate in many voices simultaneously, blending recollection and presence into a single flowing tune. Particular formicids cultivate complete mycelial plots underground. Beneath the woodland base, there are cavities excavated through earth where groups nurture mycelia with remarkable diligence. The formicids collect foliage, cleanse them thoroughly, and use them as a foundation for the mycelia to proliferate. Laborers tend these plots day and night, pruning damaged segments and supplying fresh vegetation matter to the expanding lattice. The mycelia provides nourishment to the group. In return, the formicids shield it from nuisances and rival entities. Trails extend from the nest into the surrounding woodland, forming intricate routes used for gathering. Each trail mirrors the group's needs at that instant. The underground plots remain warm and humid, sustained through exact airflow created by the arrangement of tunnels. These animated farms have existed for innumerable generations, evolving alongside the formicids. Observing them discloses a partnership so refined that no segment of the group endures alone. Together, they form one of nature's most ancient instances of cultivation. There are primates that vocalize so powerfully you can hear them leagues away. Vocalizing primates employ profound, echoing summons that roll through the woodland like remote thunder. Their enlarged vocal chambers and specialized throats allow them to project sound across vast expanses. At daybreak and twilight, groups convey their position to others, reducing disputes by informing neighboring bands of their whereabouts. The summons vibrate through foliage, drift along waterways, and ascend through the overhead. Hearing them initially can be startling because the sound is potent enough to seem much nearer than it is. Despite their intense voices, vocalizing primates often lead tranquil, leisurely lives. They repose for much of the day, preserving energy by consuming foliage that offers minimal fuel. Their vocal potency contrasts beautifully with their tender motions. They play a crucial role in kernel dispersal, helping juvenile vegetation take root far from their progenitor arboreal. Electric azure amphibians dwell among dropped foliage, alerting hunters with their vividness. Their brilliant coloration announces their presence boldly, signaling to potential hunters that they do not make simple quarry. These amphibians carry natural venoms produced through their intake of formicids and small bugs. The brilliance of their epidermis reflects radiance in a way that catches the eye even in dim underbrush. Despite their scale, they play a significant role in controlling bug populations. Their summons are soft compared to their striking hues, forming gentle chirps that blend into the background. They nurture their young in small liquid pools held within vegetation, transporting larvae one by one to secure cradles. Every motion they make reveals a balance between susceptibility and strength. Their presence adds flashes of hue to the woodland base, turning the quiet domain of dropped foliage into a landscape of tiny marvels. Particular woodland nebulas are generated from the arboreal themselves. When radiance warms the overhead, it liberates aromas, essences, and dampness into the atmosphere. These invisible particulates ascend and begin to aggregate, attracting vapor that adheres to them. As more vapor collects, small beads form and slowly merge into nebulas. These newborn nebulas drift above the woodland, sometimes remaining low enough to brush the foliage, sometimes ascending high into the heavens. Their forms change constantly, molded by the movement of warm atmosphere rising from the woodland below. When conditions align, these arboreal-generated nebulas contribute to local tempests that hydrate the terrain. This mechanism shows how closely the atmosphere and the woodland are intertwined. The woodland does not simply exist beneath the sky, it participates in molding the sky. Each nebula that forms carries a trace of the frond, rind, and respiration of the woodland, turning the atmosphere into a canvas painted by living arboreal. Waterways in the woodland can abruptly become acidic from descending foliage. As foliage drops into the liquid and begins to decompose, they liberate tannins that darken the waterway and modify its chemistry. These tannins can impart the liquid a deep tea-colored tint and create acidic conditions that influence which kinds can flourish. Some aquatic vertebrates prefer these obscure liquids because they offer protection from hunters. Others rely on the chemical shift to trigger reproduction behaviors. The acidity also affects the growth of aquatic vegetation, molding the underwater scenery in subtle ways. During certain periods when foliage descent increases, the transformation becomes rapid. The waterway changes character almost overnight. This natural mechanism has occurred for ages, maintaining equilibrium within the habitat. Even hunters like fluvial cetaceans and crocodilians adjust to the altered clarity and aroma of the liquid. These changing conditions reveal how closely connected the woodland base and waterway currents truly are. A solitary frond can ripple through an entire habitat. Arboreal that dwell in inundated woodlands can respire through their rind. In areas where liquid covers the radicals for extended periods, certain arboreal have evolved remarkable adaptations that allow them to endure. Their rind contains specialized tissues that permit oxygen to pass inward even when the shaft is submerged. This ability acts like a natural breathing tube, delivering atmosphere to the living cells beneath the surface. Some kinds grow swollen bases or flared supports that help hold them steady in shifting currents. Others develop channels within their shafts that move oxygen downward toward the radicals. These adaptations allow the arboreal to remain vital in conditions that would suffocate most vegetation. During long inundations, the woodland seems almost motionless. Yet these submerged shafts continue exchanging gases with the surrounding atmosphere. When the liquids finally recede, the arboreal resume normal growth as though nothing unusual has happened. The woodland base can vanish underwater for half the year. In certain regions, periodic rains transform the scenery so thoroughly that the distinction between terrain and waterway disappears. Liquid rises inch by inch until the underbrush is submerged. Vegetation that usually clings to earth finds itself swaying in gentle currents. Aquatic vertebrates swim over radicals that were once hidden beneath dry foliage. Avians perch on limbs now reflected in still pools. Many fauna adapt their behavior to this temporary domain. Some retreat to higher terrain, while others venture into newly reachable areas. The earth beneath the liquid absorbs sustenance washed in by the inundation, creating fertile conditions for future growth. When the liquids retreat, the terrain emerges renewed. Kernels germinate in the freshly enriched earth. Footpaths reappear. Small furry animals return to forage. This cycle sustains the woodland and shapes the lifetimes of countless kinds. The temporary disappearance of the woodland base reveals the fluid nature of woodland habitats. Some aquatic vertebrates migrate through woodlands instead of waterways. When periodic inundations spread liquid across the terrain, aquatic vertebrates take advantage of the expanded dwelling. They move through submerged underbrush, weaving between arboreal shafts and fallen limbs. This journey allows them to reach fruit-bearing arboreal whose offerings drop directly into the liquid. Many kinds rely on these periodic meals to gain strength for reproduction. The new roots also provide access to safe cradles where hunters find it harder to pursue them. Juvenile aquatic vertebrates shelter among radicals and foliage debris, feeding on bugs washed from the earth. As liquids recede, the aquatic vertebrates return to the main channels, carrying the next generation with them. These migrations reflect a deep connection between aquatic vertebrates and woodland. They show that boundaries between terrain and liquid shift constantly in the woodland. When aquatic vertebrates glide through a sunlit grove that once held walking fauna, the scenery reveals its dual identity as both woodland and aquatic expanse. Electrical discharges can ignite blazes even in the most humid locales on the planet. Although woodlands are renowned for constant dampness, potent electrical strikes can kindle dry pockets of foliage or limbs that have been warmed by radiance. Once a small flame initiates, it may smolder quietly for days before conditions permit it to spread. These blazes often remain low to the terrain and move slowly, clearing detritus without destroying the overhead. In doing so, they create space for new vegetation to grow. Some kinds even depend on occasional blaze to germinate kernels or clear competition. Fauna sense the change swiftly and relocate to safer areas until the flames pass. Afterward, the woodland base bursts with fresh growth. Verdant shoots rise through residue and bugs return to reclaim their dwellings. These natural blazes remind us that even in landscapes defined by precipitation, fire plays a role in renewal. The woodland contains cycles shaped by both liquid and flame. The cadence of woodland precipitation changes with the lunar phases. As the moon progresses through its stages, subtle shifts occur in tides, gusts, and atmospheric pressure. These changes influence humidity and nebula formation over the woodland. During certain lunar phases, precipitation becomes more frequent and falls in softer, more evenly spaced showers. During others, tempests can build with greater intensity. Fauna respond instinctively to these cycles. Amphibians summon more often under certain moonlit skies. Bugs emerge at times when moisture levels rise. Vegetation releases aromas or pollen that drift more easily in the damp night atmosphere. The interplay between moonlight and downpour creates a soft heartbeat that pulses through the woodland each month. This cadence has continued for ages, guiding relocations, flowering cycles, and the quiet unfolding of night. To heed the woodland under a full moon is to sense a connection between heavens and terrain that unfolds in patterns older than recollection. Some woodland blossoms flower for a single evening, then disappear eternally. These scarce petals wait through periods of quiet growth, amassing energy until the precise conditions align. When warmth, dampness, and moonlight meet in perfect harmony, the blossom unfurls in silence. Its petals radiate faintly in the darkness as though lit from within. Sweet aromas drift into the atmosphere, calling nocturnal fertilizing agents like lepidopterans. The bloom endures only until dawn when the first rays touch the petals. By morning, the blossom closes forever and begins to wilt, leaving behind only a developing produce or kernel pod. This fleeting display ensures that fertilizing agents are drawn to the moment with full attention because the opportunity will never recur. Some vegetation produce these blossoms only once in many years. Others bloom at irregular intervals that investigators still struggle to predict. Witnessing such a blossom feels like observing time pause, offering a glimpse of something delicate and profound that the woodland carefully guards. There are arboreal that exude crimson when incised. In the deeper parts of the woodland, certain arboreal release vivid scarlet resin when their rind is pierced. The resin oozes slowly, bright against the dark shaft, spreading into patterns that resemble flowing pigment. This striking hue comes from natural compounds that protect the arboreal from bugs and microbes. The thick fluid forms a seal over the wound, preventing further damage while also discouraging fauna from feeding on the exposed tissue. Many cultures traditionally use this resin in ceremonies or remedies because its appearance evokes a sense of vital force and endurance. Despite the dramatic sight, the arboreal experiences no discomfort. It simply responds to injury with a protective mechanism evolved over countless generations. Avians, bugs, and small furry animals sometimes investigate the aroma and texture, attracted by its unusual properties. These arboreal demonstrate the woodland's ability to surprise, revealing beauty even in moments of damage or stress. Certain creepers develop in helices to ascend more efficiently. These creepers coil upward in graceful curves, wrapping around limbs and shafts in patterns shaped by illumination and gravity. Their helical growth allows them to rise quickly toward the overhead without needing a thick self-supporting stem. Each twist strengthens their hold, distributing weight evenly so they can stretch remarkable distances without fracturing. As they ascend, they adjust their direction based on subtle cues in the environment, reaching toward patches of brightness that filter through the foliage. Their movements are slow yet constant, shifting position day by day as they explore new footholds. Fauna use the creepers as pathways between arboreal, turning them into natural bridges woven through the woodland. Some creepers develop specialized structures that help them grip rough rind or smooth surfaces. The helical shapes they create add elegance and texture to the woodland, forming intricate networks that connect different layers of this towering habitat. Some woodland vegetation can ensnare and assimilate bugs. In nutrient-scarce earth, certain vegetation have evolved extraordinary strategies to endure. Their foliage forms receptacles, adhesive surfaces, or delicate mandibles that lure bugs with aroma or glistening beads. Once the unsuspecting visitor alights, the structure closes or holds the bug in place. Assimilative fluids begin to break down the quarry, allowing the vegetation to absorb essential sustenance. These carnivorous vegetation do not rely solely on bugs, but the additional nourishment helps them flourish in areas where other vegetation struggle. Illumination plays a major role in guiding their behavior. Some kinds adjust the angle of their traps to collect precipitation without washing away potential quarry. Others rely on ultraviolet patterns invisible to humans that draw bugs into their reach. These vegetation show how existence in the woodland adapts creatively to the challenges of limited resources. Their presence adds a sense of wonder to the woodland base, reminding us that even the quietest greenery can possess surprising powers. There are kernels in the woodland that can endure being ingested and expelled by pachyderms. Pachyderms swallow produce whole, their powerful assimilative systems breaking down flesh while leaving certain kernels unharmed. As the fauna travel long distances, they deposit the kernels far from the progenitor arboreal, embedded in nutrient-abundant material that helps them sprout. This journey not only spreads the kind across the scenery, but also increases the chance that the sprouts will grow in a location with adequate illumination and space. Some kernels even require the rough passage through a pachyderm's assimilative tract to crack their outer shells and activate germination. This remarkable partnership has evolved over ages, molding the structure of entire woodlands. Without pachyderms, many of these arboreal would struggle to reproduce effectively. Their relationship demonstrates how large fauna can act as cultivators of the woodland, carrying the next generation of existence through waterways, valleys, and dense underbrush. A solitary woodland arboreal can harbor more than 1,000 distinct bug kinds. Within the limbs, rind, foliage, radicles, and hollow spaces of one mature arboreal lives a bustling domain of tiny beings. Each bug finds its own niche, from coleopterans that burrow into decaying timber to lepidopteran larvae that hide among curled foliage. Formicid colonies may build nests in the shaft, while arachnids weave delicate homes among the limbs. Some bugs feed on resin, while others graze on the algae and mycelia growing along the rind. The diversity comes from the arboreal's ability to create numerous micro-dwellings, each with its own temperature, humidity, and food sources. Even the areas exposed to radiance differ greatly from the shaded spaces near the radicals. These layered environments support complex food chains where bugs interact in ways that ripple outward through the entire woodland. The sheer variety of existence contained within one arboreal illustrates how densely packed woodland habitats can be. There are vegetation that mimic the appearance of other vegetation to endure. These clever imitators shape their foliage, hues, and growth patterns to resemble neighboring kinds. By blending in, they avoid detection by herbivores that might otherwise consume them. Some mimic venomous vegetation so convincingly that fauna avoid them without hesitation. Others copy the growth habit of tougher kinds, giving the illusion of strength they do not actually possess. Their deception extends through entire periods as they adjust subtle traits based on the conditions around them. Even bugs can be fooled, sometimes depositing over on the wrong vegetation because of a well-crafted disguise. This mimicry allows the vegetation to conserve energy that would otherwise be spent producing venoms or repairing damage. Their survival depends on being overlooked, and the woodland offers endless opportunities for disguise. The practice shows how existence in dense habitats evolves through delicate balances of adaptation and camouflage. Some woodland arboreal release compounds that prevent other vegetation from growing nearby. To reduce competition, these arboreal send substances into the earth that slow or halt the growth of surrounding vegetation. These compounds seep from radicals or fallen foliage, creating a zone in which only certain kinds can flourish. This strategy ensures the arboreal has access to radiance, liquid, and sustenance without battling dense underbrush. The effect can be subtle, appearing only when sprouts try to emerge. They may fail to develop radicals or wither shortly after surfacing. Over time, the cleared space around the arboreal becomes a distinctive feature of the woodland base. Fauna notice the pattern and may use the open terrain as pathways or resting spots. Despite the competitive nature of this adaptation, it helps maintain diversity by molding the distribution of vegetation. Each compound interaction influences the structure of the woodland in ways investigators are still working to comprehend. Certain woodland mycelia can influence the behaviors of bugs. These mycelia release spores that land on unsuspecting bugs, attaching to their bodies and slowly proliferating within. As the mycelia spread, they release compounds that affect the bug's conduct. The bug begins to ascend upward, seeking elevated places where the mycelia can best release its spores. Once the bug reaches a suitable height, it attaches firmly to a frond or twig. The mycelia completes its life cycle by emerging from the bug's body and sending spores into the atmosphere. Although the process appears uncanny, it forms a natural part of the woodland's equilibrium. Other bugs, avians, and scavengers help cleanse the environment by feeding on infected individuals. Researchers study these mycelia to understand how microscopic entities can mold the behavior of larger beings. Their complex interactions reveal a domain of hidden influences where existence responds to forces that operate quietly but powerfully. Some vegetation use high-frequency vibrations to attract fertilizing agents. These remarkable vegetation emit oscillations that pulse through the atmosphere at frequencies too high for human ears to detect. Certain bugs, however, can sense these signals with great precision. When they approach, the subtle hum guides them toward blossoms that may be concealed by foliage or positioned in shaded areas. Once the fertilizing agents arrive, they find nectar arranged in patterns that match the shape of their bodies. The high-frequency vibrations may also help loosen pollen or warm the floral tissue slightly, making the bloom more inviting. This communication method allows the vegetation to reach fertilizing agents even in dense woodland, where visual cues can be limited. It represents a sophisticated form of interaction molded through countless evolutionary cycles. Each transmission of vibration reflects the vegetation's attempt to overcome obstacles of shadow and distance, drawing existence toward itself by means other than sight or aroma. Some woodlands are older than the Amazon waterway itself. In certain parts of the world, ancient woodlands began forming long before the Amazon waterway carved its initial path across the continent. These woodlands grew during eras when Earth's atmosphere, oceans, and temperatures were profoundly different from today. Layer after layer of vegetation rose and fell across ages that stretched beyond human comprehension. As continents drifted and mountains rose, these woodlands adapted to shifting gusts, changing downpour, and new forms of existence that appeared across the planet. Their earths became deep reservoirs of memory, built from countless generations of fallen foliage that decomposed slowly in the humid atmosphere. Within these layers lie chemical traces of climates long vanished, along with the fossilized remains of bugs and vegetation that once dominated the scenery. Arboreal that live here today share ancestry with kinds that survived immense transitions and global transformations. When you traverse beneath their limbs, the stillness feels ancient, as though the woodland carries the patience of time itself. These regions remind us that the woodland is not simply a dwelling, but a survivor of worlds that rose and vanished before modern habitats even began to form. Fossils indicate that primordial woodlands once flourished in Antarctica. Long before the continent became encased in ice, Antarctica held woodlands that thrived under unique conditions of nearly continuous summer radiance and extended winter obscurity. Deep within its rocks, investigators have discovered frond impressions, petrified timber, and delicate structures from ferns and kernel vegetation that once spread across a warm and humid scenery. These fossils preserve the fine textures of fronds and the intricate patterns of ancient rind, showing that existence once flourished where frozen wastelands now dominate. The arboreal grew slowly yet steadily, adapting to long periods without direct radiance by storing energy during bright periods. Bugs likely scurried across the foliage debris, feeding on decaying material in a domain that felt more like a modern woodland than a polar continent. Studying these remnants offers insight into how climates can shift over immense spans of time. The presence of primordial woodlands beneath present-day ice reminds us that Earth has never been static. It respires, changes, warms, cools, and reshapes itself again and again as existence adapts in extraordinary ways. The genetic material of woodland vegetation holds clues to Earth's earliest habitats. When researchers analyze the genetic structures of vegetation that thrive in woodlands, they find traces of evolutionary chapters written long before humans existed. Some genes within these vegetation link directly to early terrain vegetation from a time when Earth was still experimenting with the first radicals, stems, and protective coatings. Other sections of genetic material reveal relationships between vegetation that appear dramatically different on the surface, yet share deep connections in their ancestry. These genetic signatures help investigators understand how early habitats functioned and how vegetation responded to ancient patterns of aridity, inundation, volcanic activity, and atmospheric change. Some woodland kinds show remarkable genetic stability through time, suggesting that their environments remained supportive and steady for millions of years. Others contain evidence of sudden bursts of evolution when climate or geography shifted in ways that forced rapid adaptation. Each frond and kernel carries an archive of information that cannot be found in rocks alone. By examining these living codes, researchers glimpse the long arc of vegetation evolution and the intricate history of the habitats that eventually molded modern woodlands. Some bug lineages in woodlands have remained unaltered for millions of years. In the quiet spaces beneath foliage and along the rind of towering arboreal, there exist bugs that resemble beings preserved in ancient resin. Their body shapes, feeding habits, and life cycles mirror the forms that existed during eras when enormous reptiles roamed across warm and humid landscapes. These bugs survived countless climatic shifts by retaining strategies that worked so well they required little modification. They continued fertilizing vegetation, breaking down decaying matter, and serving as quarry for larger fauna, just as their ancestors did in primordial woodlands. Modern researchers studying their behavior see patterns so old that they stretch across geological ages. The persistence of these lineages provides a living connection to habitats that no longer exist. When one observes a small coleopteran crawl across a fallen limb, it is possible to imagine the same motion taking place millions of years ago in woodlands now lost to time. Their survival demonstrates how certain designs remain effective and how stable woodland environments can preserve ancient existence for astonishing lengths of time. Tropical woodlands were once the cradle of flowering vegetation. Deep in the distant past, when early woodlands covered vast regions of a warm planet, the first flowering vegetation began to experiment with new forms of reproduction. Before this moment, most vegetation relied on gust or liquid to move their spores. The arrival of flowers created new partnerships between vegetation and bugs. These early blooms produced aromas, hues, and shapes that drew fertilizing agents toward them. As bugs traveled between blossoms, they carried genetic material from one vegetation to another, encouraging rapid diversification. Tropical woodlands provided an ideal environment for this explosion of creativity because they offered stable temperatures, abundant downpour, and constant opportunities for interaction among kinds. Over time, flowering vegetation spread outward from these warm cradles into other dwellings, transforming habitats with produce, kernels, and intricate reproductive cycles. The modern woodland still holds descendants of those early pioneers. Within their petals lie echoes of the moment when Earth shifted from simple vegetation forms to the lush diversity that now covers much of the planet. Some woodland kinds trace their ancestry to when dinosaurs roamed the Earth. In remote corners of tropical woodlands, entities thrive that have changed very little since ancient times. Certain ferns unfurl fronds that closely resemble fossilized foliage found in strata dating back to eras when giant reptiles dominated the terrain. Some reptiles and amphibians move through foliage debris with behaviors that echo their prehistoric ancestors. Even a few bugs display patterns and wing structures matching those preserved in resin from the time of dinosaurs. These kinds survived mass extinctions by retreating into stable, sheltered environments where humidity, temperature, and illumination remained steady. The woodland acted as a refuge when global circumstances shifted violently. Today, these living relics continue their ancient routines as though untouched by the march of deep time. Observing them evokes a sense of wonder, for they offer a direct link to worlds that vanished long before humans emerged. Certain woodland arboreal are living fossils from a vanished domain. These arboreal stand as remnants of eras that predate many mountain ranges and continents in their current positions. Their foliage often follows patterns seen in fossil collections more than 100 million years old. Their kernels and cones maintain structures that reflect early experiments in vegetation reproduction. They flourish in small pockets where environmental conditions mimic those of their distant past. Some grow slowly in shaded ravines that preserve ancient humidity levels. Others stand on mountain slopes where temperatures remain steady throughout the year. Because they survived so long, they carry unique genetic information that helps investigators reconstruct the evolution of vegetation existence. Each shaft rises like a pillar of recollection, connecting the present to chapters of Earth's history that would otherwise remain silent. Standing beneath one of these arboreal can feel like entering a sanctuary built by time itself. Woodland sediments preserve the stories of Earth's climate past. In the quiet depths of woodland ponds, in slow-moving flood plains, and beneath still liquids that collect between radicals, fine particles settle year after year. These layers trap pollen, spores, minerals, charcoal, and fragments of foliage that drift down from the overhead. Over centuries, they stack gently into timelines that investigators can read like journals. The presence or absence of certain pollen types reveals which kinds dominated the woodland at different periods. Shifts in mineral content show how rains changed or how distant volcanic eruptions altered the atmosphere. Even tiny pieces of charcoal tell of ancient blazes that moved through the woodland long before written history began. When researchers extract sediment cores from these quiet places, they unravel the climate stories of thousands of years. Each layer reveals how the woodland responded to aridities, inundations, and transitions in global temperature. The sediments hold these memories patiently, waiting for those who know how to interpret them. The oldest known woodland arboreal kinds may date back over 100 million years. Hidden within the vast diversity of tropical woodlands are kinds whose genetic roots reach into a time before many modern vegetation groups had even appeared. The ancestors of these arboreal lived through shifting continents, rising seas, and dramatic climate swings. Their foliage still follows patterns shaped in ancient climates, and their reproductive cycles preserve methods developed long before flowering vegetation reached their full diversity. These arboreal have endured because the woodland offered stability across unimaginable spans of time. Within their rind, lie chemical traces of ancient processes that continue even now. Their kernels fall into earth enriched by countless generations of predecessors, continuing a lineage that began when enormous reptiles still wandered the earth. To touch the shaft of such an arboreal is to make contact with an age so distant that it feels almost mythic. Some woodland entities evolved alongside extinct colossal fauna. Long ago, woodlands echoed with the sounds of enormous herbivores that fed on foliage, rind, and produce in abundance. Many vegetation adapted their structures to withstand browsing by these giants. Some developed thick protective coverings around their produce. Others grew large kernels that needed to pass through massive assimilative systems before they could germinate properly. When the colossal fauna eventually disappeared, many of the vegetation survived despite losing their original partners. Their traits remain as echoes of ancient relationships. Even some bugs appear to have co-evolved with these towering fauna, feeding on materials created by their movements or waste. Today, these vegetation and bugs continue to display characteristics molded by an age that ended long before modern woodlands took form. They carry the imprint of interactions with beings that no longer walk the earth, reminding us that evolution is a living map of connections that stretch far into the past. A teaspoon of woodland earth can hold more microbes than there are people on earth. Within a tiny scoop of woodland soil lives a universe of entities so small and so numerous that they exceed the human population many times over. Each microbe fulfills a specific role that molds the health of the entire woodland. Some break down fallen foliage into sustenance. Others form partnerships with arboreal radicals, helping vegetation absorb minerals that would otherwise remain locked within the earth. Many kinds remain unknown to science because they cannot easily be grown or studied outside their natural environment. When researchers examine woodland earth under powerful microscopes, they see countless shapes and movements within a single drop of moisture. Some microbes drift like floating dust. Others cling to tiny mineral grains or form delicate networks that anchor them in place. Together, they create a living foundation that supports every entity above them. Without these unseen workers, the woodland would lose its ability to recycle sustenance, regulate liquid flow, and sustain new growth. The earth becomes a quiet domain where existence thrives in miniature, proving that even the smallest spaces in the woodland hold astonishing abundance. There are mycelia that live entirely inside foliage, never touching the atmosphere. These mycelia spend their entire lives within the delicate tissues of foliage, weaving through microscopic spaces between vegetation cells. They remain invisible to the naked eye, forming intricate networks that help protect the frond from harm. Some strengthen the vegetation by defending it against invading microbes. Others produce compounds that deter bugs from chewing through the frond surface. Because they never emerge into open atmosphere, they avoid drying out and remain shielded from hunters. The vegetation benefits from their presence, and the mycelia rely on the stable environment within the frond. This partnership often lasts for the entire lifespan of the vegetation tissue. When the frond eventually falls, the mycelia help decompose it, returning sustenance to the earth. Their existence reveals a hidden dimension of woodland existence where entire habitats unfold inside spaces too small for humans to see. These mycelia expand our understanding of biodiversity and show that the woodland contains layers of existence within. Woodland contains layers of existence within layers of existence. Some saurians change hue to match the shadows of different arboreal. In the shifting illumination beneath the overhead, certain saurians possess an extraordinary ability to alter their hue so they blend with the precise shade of the limb or rind they rest upon. Their epidermis contains specialized cells that expand or contract to adjust the mixture of pigments visible from the surface. These adjustments occur in response to illumination intensity, temperature, mood, and the patterns surrounding them. When a nebula drifts overhead and casts a cooler tint across the woodland, the saurian subtly darkens to remain concealed. When radiance pierces through the foliage and paints the domain with warmer tones, its epidermis brightens. This constant adaptation allows the saurian to avoid hunters and approach quarry without detection. Investigators studying this phenomenon find that each kind responds to specific cues that reflect its unique ecological niche. The woodland becomes a living stage where hue flows in harmony with illumination, shadow, and motion. Woodland chiropterans use acoustic navigation to maneuver tangled jungle corridors. As night envelops the woodland, chiropterans take to the atmosphere with astonishing precision. They emit high-frequency pulses that bounce off limbs, creepers, bugs, and shafts. The returning echoes form a detailed map within their minds, allowing them to move swiftly through dense vegetation without ever brushing a frond. Each pulse reveals distance, shape, and direction, creating an ever-shifting acoustic image of their surroundings. These chiropterans hunt lepidopterans and coleopterans that also fly in darkness, adjusting their flight path midair with remarkable speed. Some kinds communicate with one another through variations in their summons, coordinating movements within shared pursuit territories. Their ability to navigate through such complex environments demonstrates the sophistication of acoustic location. When they glide among arboreal shafts that twist in unpredictable patterns, they depend entirely on sound and instinct. Watching a chiropteran weave through the woodland at night is like observing a being reading invisible pathways known only to sound and motion. The humidity inside a woodland orchid can reach near boiling levels. Hidden within the folds of an orchid blossom lies a pocket of atmosphere that can trap heat and moisture to an astonishing degree. As radiance warms the petals, the space within becomes a sheltered chamber where humidity builds to extreme levels. This warm interior creates an ideal environment for delicate reproductive processes. Fertilizing agents that enter the blossom find themselves surrounded by thick moisture that enhances the release of aroma and assists in pollen transfer. Some bugs remain inside for brief periods, feeding on nectar, while the orchid ensures successful fertilization. The heat trapped within the bloom also discourages small hunters that might otherwise damage its fragile structures. Each orchid kind molds the internal climate of its blossoms with remarkable precision, adjusting the size and curve of the petals to regulate airflow. This hidden domain exists only for a short time before the bloom wilts and returns its energy to the vegetation. Within these ephemeral chambers, the woodland reveals another example of how nature engineers intricate environments on a scale small enough to disappear with a closing petal. Some bryophytes in the woodland radiate under ultraviolet illumination. On dim woodland bases where radiance arrives in scattered fragments, certain bryophytes contain pigments that emit a soft radiance when touched by ultraviolet rays. Although this glow is invisible during ordinary daylight, it becomes visible under the special wavelengths present at dawn, dusk, or during low illumination periods. The glow may help attract bugs that assist in spore dispersal or may protect the bryophyte from damage caused by intense radiation. These pigments form delicate patterns across the bryophyte's surface, creating a subtle shimmer that blends with the damp earth and fallen foliage. Investigators studying these kinds find that each type of bryophyte produces its own distinctive glow, almost like a quiet signature left upon the woodland base. The radiance highlights the beauty of entities often overlooked because of their size. In the presence of ultraviolet illumination, these tiny clumps reveal an unexpected brilliance that turns a shaded corner of the woodland into a gentle constellation of living verdant stars. There are myriapods in the woodland that prey on chiropterans. Within the darkness of caverns and hollow arboreal, enormous myriapods climb walls with silent precision. Their appendages grip even the smoothest surfaces, allowing them to position themselves just below roosting chiropterans. When a chiropteran drops lower or shifts to a vulnerable angle, the myriapod lunges upward using strong mandibles to seize the being in midair. It coils its long body around the struggling chiropteran until movement ceases. This surprising predator relationship shows how woodland existence can push the boundaries of what seems possible. The myriapod's sensory organs help it detect heat and vibration, giving it an advantage in the darkness. Despite their impressive abilities, these beings rarely encounter humans because they prefer hidden spaces. Their existence illustrates how hunters come in many forms in the woodland, some unexpected and astonishing. Observing such interactions deepens our understanding of food webs that operate far from daylight. In the woodland, even liquid beads can become miniature habitats. After a downpour, beads cling to foliage, limbs, and delicate bryophyte beds. Within each bead, microorganisms begin to gather. Some drift in on the gust, others wash down from higher overhead layers. These beads can contain entire chains of existence, from tiny plankton-like beings to microscopic hunters that feed on smaller entities. The chemistry within each bead shifts as radiance warms it and as sustenance dissolves from the frond surface. Some bugs rely on these beads to lay ova that hatch into larvae. Amphibians may deposit their young in larger pools held within curled foliage. Each bead becomes a tiny domain that lasts only until it evaporates or falls to the earth. Yet in that brief time, it holds interactions that mirror larger habitats. Energy flows from radiance to microbes to hunters in cycles too small for human eyes to follow without specialized tools. The woodland reminds us that existence flourishes at every scale. Tiny coleopterans can survive the pressure of falling from a 100-foot arboreal. In the overhead, mishaps happen constantly. Gust shakes limbs, hunters scatter quarry. Foliage releases its grip on bugs resting upon them. When a coleopteran tumbles from a great height, it does not break. Instead, its small size and rigid body structure allow it to ride the atmosphere, slowing its descent through a combination of lift and passive resistance. Many coleopterans curl their appendages inward and let their body rotate gently as they fall. Some even spread microscopic hairs that increase atmosphere resistance just enough to reduce impact force. By the time they reach the woodland base, they land almost as lightly as drifting kernels. This remarkable resilience allows them to explore the overhead without fear of fatal accidents. Their ability to survive such significant falls contributes to their success in the woodland environment where vertical space is as important as horizontal terrain. Some winged insects have transparent wings that shimmer like glass. In radiance, these winged insects appear almost invisible, except for faint outlines that flicker as they move. Their wings contain specialized scales spaced far apart, allowing illumination to pass through rather than reflect it. This transparency provides exceptional disguise because hunters struggle to track something that blends with the shifting hues of the woodland. When the winged insect tilts its wings, certain angles catch the illumination and produce gentle flashes that look like tiny panes of colored glass. These subtle gleams are not meant to be warnings, but rather a side effect of delicate wing structure. The winged insects settle on foliage where their bodies become nearly impossible to see unless one observes the faint movement of antennae. Their presence adds an ethereal touch to the woodland, as though fragments of the heavens drift silently among the arboreal. At night, the woodland sings with thousands of unseen voices. When darkness settles over the overhead, the woodland awakens into a symphony woven from countless beings. Amphibians begin the chorus, their summons rising from pools, limbs, and curled foliage that cradle beads of liquid. Bugs respond with vibrating wings that create shimmering tones. Furry animals add soft rustles as they move through the underbrush. Even the arboreal contribute subtle sounds as cooling atmosphere shifts through their towering limbs. The woodland seems to inhale and exhale in rhythms molded by nocturnal existence. Many of these voices belong to kinds that hide from daylight, emerging only when shadows deepen. Each sound carries information about territory, courtship, danger, or discovery. Yet the layers overlap in ways that create a tapestry rather than chaos. As you listen, patterns emerge that reveal how deeply connected these fauna are to one another and to the terrain itself. The night chorus becomes a reminder that the woodland never slumbers. It simply changes the language through which existence expresses itself. There are blossoms that only open under the full moon. In secluded pockets of the woodland, certain vegetation wait for the exact brightness of a full moon before unfurling their petals. These blossoms rely on pale illumination that filters through the overhead, guiding nocturnal fertilizing agents directly toward them. Their petals often appear white or silvery, so they glow gently under lunar radiance. The atmosphere around them fills with aroma that intensifies only during these nights, drawing lepidopterans and coleopterans that navigate by moonlight. The bloom is brief and precise, timed to align with the cycles of the heavens. When the moon begins to wane, the blossoms close once again, conserving energy until the next period of ideal illumination returns. These vegetation embody a relationship between terrain and heavens that unfolds quietly yet with astonishing accuracy. Their blooms become fleeting celebrations of celestial timing and the deep intelligence of nature. Nocturnal primates leap silently through the limbs in pitch darkness. In the deepest night, when even moonlight struggles to penetrate the overhead, certain primates move with astonishing grace. They rely on finely tuned senses other than sight, such as acute hearing and an ability to detect subtle changes in atmosphere movement. Their hands and feet grip rind with practiced familiarity as they judge distances through memory, instinct, and the faint texture of surrounding limbs. These primates travel in family groups that communicate with gentle clicks or soft notes that do not disturb slumbering beings nearby. They forage for produce or bugs hidden within curled foliage, using touch to replace the guidance of illumination. Watching them reveals how fully fauna adapt to nocturnal existence. They do not hesitate even when leaping across wide gaps. Their bodies seem molded for darkness, navigating a domain that appears invisible to human eyes, yet perfectly clear to them. Luminescent mycelia illuminate the woodland base like stars. When night deepens and moisture thickens the atmosphere, small clusters of mycelia begin to glow with soft green or blue radiance. This illumination emerges from chemical reactions within their cells that occur when the mycelia break down decaying material. The glow is often subtle, visible only when all other illumination fades. Yet in completely dark spaces, the woodland base can take on an otherworldly appearance dotted with faint points that resemble scattered stars. Bugs drawn to the glow may help spread spores as they land and explore the illuminated surfaces. Some mycelia brighten after downpour, while others glow most intensely when approaching maturity. Investigators continue to study why these kinds produce illumination, yet each discovery reveals deeper complexity. The woodland becomes a cosmic scenery beneath the overhead, where decay transforms into delicate gradients. This quiet glow reminds us that existence can express beauty even in its final stages. Night vision serpents glide through black liquid under a canopy of silence. In inundated woodlands, certain serpents move effortlessly through dark liquid without relying on visible illumination. Their bodies contain heat-sensing structures that allow them to detect the warmth of quarry hidden among radicals or drifting limbs. They slip between submerged logs with fluid movements, disturbing nothing as they pass. Their eyes gather whatever faint illumination exists, while their tongues sample chemical traces carried by the current. These serpents often hunt aquatic vertebrates, amphibians, or small furry animals that venture near the liquid's edge. Their presence becomes known only by the brief ripple that trails behind them. The woodland around them remains quiet, as though holding its breath. The serpent's journey through the dark liquid reflects the deep subtlety of nocturnal existence, where survival depends on senses that operate beyond human perception. Even in silence, the woodland brims with unseen movement and purpose. Some lepidopterans hear the acoustic location summons of chiropterans and evade them mid-flight. In aerial battles invisible to the eye, lepidopterans have evolved extraordinary hearing organs that detect the high-frequency pulses emitted by pursuing chiropterans. When these pulses reach them, the lepidopteran reacts instantly, folding its wings or altering its flight pattern with unpredictable twists. Some dive sharply downward, while others veer into chaotic paths that confuse hunters. These evasive maneuvers occur in fractions of a second, molded by millions of years of evolutionary pressure. The woodland sky becomes a realm of constant negotiation between pursuer and quarry. Lepidopterans that succeed pass their heightened sensitivity to the next generation, refining this remarkable survival skill. Observing them reveals the intricate arms race unfolding each night in the overhead. Their responses contribute to the delicate equilibrium of woodland habitats where adaptation defines every relationship. Tree amphibians change their hue entirely between day and night. During daylight, certain tree amphibians display bright patterns that help them blend with sunlit foliage or warn hunters of natural venoms. As night approaches, their epidermis shifts into deeper tones that conceal them among shadows. This transformation occurs through pigment cells that expand or contract within the epidermis. The process is influenced by temperature, moisture, and the subtle rhythm of the amphibian's internal clock. Once darkness settles, the amphibians climb higher into the overhead, using their altered hues to avoid nocturnal hunters. In the morning, their hues brighten once again. This daily cycle highlights the dynamic interplay between behavior, physiology, and environment. Their outer appearance becomes a living response to changing illumination, revealing how deeply beings attune themselves to the cycles of the woodland. Nocturnal coleopterans send pulses of infrared illumination invisible to the human eye. Certain coleopterans communicate at night using flashes of illumination that fall outside the visible spectrum. These pulses travel through the atmosphere in narrow beams that only other members of the kind can detect. The coleopterans use this hidden language to locate companions or coordinate movement through dense vegetation. Their bodies contain specialized structures that produce heat-based illumination in brief bursts. Because hunters cannot see these signals, the coleopterans communicate safely without attracting unwanted attention. This invisible conversation forms another layer of the woodland's nocturnal domain. Investigators studying these coleopterans often require specialized cameras to capture the signals. When viewed through this equipment, the darkness reveals a silent exchange of glowing threads. These bugs remind us that countless interactions unfold beyond our senses, and that the woodland contains entire conversations hidden within wavelengths people cannot perceive. At night, the woodland respires differently than it does by day. When the sun sets, the woodland shifts its entire cadence. Vegetation slows their release of oxygen and increase the uptake of carbon dioxide. The temperature cools, allowing moisture to condense into beads that coat foliage, creepers, and limbs. The atmosphere thickens slightly as humidity rises. Fauna adjusts to this change. Nocturnal kinds emerge to feed, while daytime beings retreat into sheltered cavities. Sounds shift from the chatter of avians to the hum of bugs and the deep summons of amphibians. Even the earth cools, releasing aromas that attract nighttime foragers. The woodland moves into a softer pattern that allows beings to repose or awaken, depending on their biological clocks. This nightly transformation illustrates the woodland's ability to operate as a vast, respiring entity with cycles that mold every living thing within it. Some carnivorous vegetation only ensnare quarry after dusk. Certain carnivorous kinds time their feeding activity with the arrival of darkness. Their traps remain open during the day, appearing harmless to bugs that wander across their surfaces. As night falls, the vegetation shifts their internal chemistry, making their surfaces more adhesive or altering the movement of trap structures. Some release subtle aromas that attract nighttime bugs seeking moisture or nectar. Once the quarry lands, the trap closes with slow yet decisive motion, beginning the process of assimilation. This nocturnal strategy allows the vegetation to avoid competition with daytime hunters while taking advantage of bugs active at night. Their ability to coordinate feeding with environmental cues demonstrates a refined adaptation to the rhythms of the woodland. Under the moonlit overhead, these quiet pursuers wait patiently for the right moment to secure nourishment. The Congo Basin woodland throbs with tempests like a living core. Across this immense scenery, weather does not simply arrive. It builds slowly within the woodland itself, gathering strength as countless arboreal release moisture into the heavens. Warm atmosphere rises in towering columns until nebulas begin to swirl above the overhead. In the distance, thunder murmurs like the slow beat of something primordial. Electrical flashes across the horizon and illuminate the shafts of colossal arboreal that have felt this cadence for ages. Precipitation begins as a soft patter barely perceptible among the ferns before swelling into a powerful deluge that sweeps through the woodland with the energy of a living pulse. Fauna sense these changes long before the first bead falls. Avians retreat into thick vegetation. Pachyderms adjust their routes. Even bugs alter their flight patterns as pressure shifts. When the precipitation arrives, it cools the atmosphere and replaces the heavy stillness with a fresh aroma rising from earth newly awakened. The tempests ebb and swell in patterns so consistent that the woodland seems to inhale in tempests and exhale calm. This cycle molds existence across the basin, nurturing vegetation and fauna that rely on the dependable cadence of sky liquid and thunder. Southeast Asia's ring woodlands echo with the summons of swinging primates at dawn as the first pale illumination touches the overhead. Swinging primates begin their elaborate melodies. Their voices rise in sweeping arcs that carry across valleys and riverbanks, weaving through creepers and drifting above treetops. Each summons contains patterns that communicate territory, companionship, and the supple cadence of family bonds. Their long arms and agile bodies allow them to swing from limb to limb with effortless grace as they sing, creating music and motion that blend into a single expression of daybreak. Other beings awaken in response. Avians answer with their own layered notes. Bugs begin their daily chorus. Even the foliage seems to vibrate as radiance grows stronger. Swinging primate families often sing together, creating harmonies that travel great distances over the humid atmosphere. These morning performances mark the beginning of the woodland's daily unfolding. The melodies act as landmarks of sound that define space and time for beings near and far. Hearing them feels like witnessing the woodland open its eyes for the first time each day. Australia's primordial woodlands shelter some of the world's rarest pouch-bearing fauna. Hidden among the lush greenery of Australia's oldest woodlands live pouch-bearing fauna found nowhere else on Earth. Some glide silently through the night on folds of epidermis that catch the humid atmosphere. Others move slowly across bryophyte-covered limbs, their large eyes designed for dim illumination filtered through ancient overheads. These kinds trace their ancestry across millions of years, surviving dramatic climate shifts and the arrival of countless new hunters and competitors. The woodland offers them shelter in the form of dense understory, cool ravines, and arboreal cavities molded by centuries of growth. Many depend on specific vegetation for food, choosing foliage, nectar, or produce that grow only in narrow ecological niches. Their existence reveals the strength of primordial habitats that preserve existence forms deeply connected to the past. To encounter one of these pouch-bearing fauna is to witness a living chapter of evolutionary history, preserved by woodlands that have endured since times long before modern fauna emerged. New Guinea's woodland is home to avians that construct elaborate courtship arenas. Within the deep verdant of New Guinea's woodland, certain avians create intricate stages designed purely for the purpose of attracting companions. These arenas often begin as simple clearings on the woodland base. Over time, the avians decorate them with carefully selected foliage, berries, sticks, and objects that catch the eye. Some arrange materials in spiral patterns. Others build small towers or archways. Each design reflects the individual's creativity and vigor. Once the arena is complete, the avian performs dances filled with sweeping gestures, fluttering movements, and precise steps that display its skills. Nearby females watch the performance and evaluate the artistry, cadence, and effort shown. The building and dancing can continue for many days as the avian refines each detail. These courtship rituals demonstrate extraordinary intelligence and persistence. They also highlight the woodland's role as a cradle for complex behaviors molded by beauty, precision, and the desire to impress. Madagascar's woodlands shelter kinds found nowhere else on Earth. Separated from other continents for millions of years, Madagascar developed habitats that evolved in near isolation. Within its woodlands, live beings so distinct that they seem like inhabitants of another domain entirely. Leaping primates bound gracefully through the overhead with movements unlike any other primates. Color-changing saurians shift their hues in response to subtle cues found in these unique dwellings. Rare vegetation produces blossoms with shapes and aromas found nowhere else. Even the woodland base contains kinds of bugs, mycelia, and reptiles that exist only on this island. The separation allowed existence to chart unusual evolutionary paths, creating forms and behaviors seen in no other woodland. Many of these entities depend on highly specific microdwellings found only in narrow regions of Madagascar. Their survival reflects both the fragility and resilience of isolated habitats. To traverse through these woodlands is to witness existence molded by deep time, guided by conditions unlike anywhere else on Earth. The Daintree woodland may be the oldest surviving tropical woodland in the world. Along the northeastern coast of Australia lies a woodland that carries the memory of ancient ages. The Daintree has endured shifting climates, rising seas, and continental movements that reshaped the surrounding terrain. Many vegetation kinds found here represent early branches of the evolutionary tree, maintaining forms close to their prehistoric ancestors. Creepers climb shafts that have sheltered generations of beings. Ferns unfurl fronds that echo patterns found in fossils dating back tens of millions of years. The woodland streams flow through landscapes molded by a lineage of vegetation and fauna that survived when others disappeared. Some bugs and avians found in these woodlands retain traits linking them to ancient lineages. The The Daintree offers a rare window into what early tropical woodlands may have looked like long before modern habitats formed. Walking within its shadows feels like stepping into a time that predates human history, carried forward by the patience of nature. Borneo's jungle overhead is alive with red apes, gliding fauna, and climbing ursids. High above the woodland base, Borneo's overhead forms an interconnected domain where beings move with astonishing independence from the terrain. Red apes travel through this elevated realm using powerful arms to navigate from arboreal to arboreal in search of produce, foliage, and rind. Beneath their pathways glide small furry animals that spread membranes of epidermis and float silently from limb to limb. Some ursids climb thick shafts with strong claws to reach honey hidden within arboreal cavities. Each kind uses the overhead in unique ways, turning it into a layered network of activity. The limbs act as highways for motion, communication, and feeding. Even vegetation adapt to this high environment by developing foliage that capture radiance filtered through many layers of verdant. Existence in Borneo's overhead demonstrates how richness multiplies when kinds explore different levels of the same woodland. Sri Lanka's wet zone woodlands bloom with blossoms not found on any other continent. In the lush wet zones of Sri Lanka, precipitation nourishes woodlands that burst into color with exquisite petals found nowhere else in the world. Some blossoms unfold only in the dim illumination beneath dense overheads. Others bloom along mist-covered cliffs where cool gusts carry their aromas across the scenery. Many vegetation depend on highly specialized fertilizing agents, creating relationships that evolved through countless generations. Avians with bright plumage visit certain blossoms exclusively, while bugs navigate intricate shapes designed to guide their movements. These unique petals mirror the island's long history of isolation and shifting climate. Their presence creates periodic spectacles across the woodland, transforming verdant landscapes into scenes of vibrant hue. Each bloom expresses the island's deep ecological identity and adds to the diversity that draws researchers and visitors from around the globe. Central America's woodlands form narrow corridors teeming with panthers and colorful-billed avians. Stretching between continents, these woodlands create living bridges that allow kinds to travel across great distances. Panthers roam through shadowed underbrush, following primordial paths that cross waterways and mountains. Colorful-billed avians glide between fruit-bearing arboreal with bright bills that stand out against the overhead. Many kinds rely on these corridors to maintain healthy populations, moving from region to region in search of new foraging grounds or companions. The woodlands themselves change gradually along the corridor, blending distinct habitats into a mosaic of dwellings. Each region supports beings adapted to subtle shifts in downpour, altitude, and vegetation. These connected pathways sustain the motion of existence across Central America, linking beings in a web that stretches from one ocean to the other. The corridors become highways of biodiversity where hunters, fertilizing agents, and migrants maintain equilibrium across the terrain. Even Hawaii once held tropical woodlands filled with lost legends and lava arboreal. Long before large human settlements, Hawaii's volcanic mountains were draped in thick woodlands where unique avians sang from limbs coated in bryophyte and mist. Lava flows from primordial eruptions cooled beneath the woodlands and left behind hollow pillars known as lava arboreal. These natural sculptures formed when molten rocks surged around living shafts and then hardened while the arboreal burned away. Over time, vegetation returned to these landscapes, creating environments rich with kinds found nowhere else on the planet. The woodlands once sheltered nectar-feeding avians with vivid plumage, bugs that evolved specialized feeding habits, and vegetation that flourished in volcanic earth. Many of these kinds are now rare or vanished, leaving behind traces of their presence in stories and scientific records. The remnants of Hawaii's primordial woodlands offer glimpses of domains molded by fire, liquid, and deep time, where existence adapted to the rhythms of an island still growing from the sea. Woodlands draw carbon from the atmosphere with every respiration. Each frond within the woodland acts as a living gateway between the atmosphere and the terrain. Through the quiet process of light synthesis, vegetation draw carbon dioxide from the atmosphere and transform it into the building blocks of their shafts, limbs, produce, and radicals. This happens every moment of every day, guided by radiance that filters through endless layers of verdant. When you stand among these arboreal, you stand in the presence of a vast machine that turns atmosphere into existence. The woodland holds this carbon not only in timber, but also in earth enriched by centuries of fallen foliage and radicals. Fauna add their own contributions as they consume, exhale, and move sustenance across the terrain. The process is steady and constant, like a deep inhale that continues across generations. Without this immense exchange, Earth's atmosphere would feel very different. Woodlands help moderate temperatures, support stable climates, and offer the world a breath of equilibrium. They do so quietly, one frond and one moment at a time. The disappearance of woodlands affects downpour thousands of miles away. Moisture released by woodland arboreal rises into the heavens where it gathers into nebulas that travel far beyond the boundaries of the woodland itself. These nebulas carry liquid across continents, feeding distant farms, waterways, and mountain ranges. When woodlands shrink, the heavens receive less moisture. Atmosphere currents lose strength and downpour patterns shift. Regions far removed from the tropics can experience aridity or unpredictable tempests because of changes that begin with arboreal loss thousands of miles away. Researchers have traced these atmospheric pathways, revealing how vapor born within a single woodland may journey across oceans before falling as precipitation in entirely different climates. This global linkage shows that woodlands act not only as local habitats, but also as engines that drive liquid cycles for the entire planet. Their loss disrupts patterns that have taken millions of years to stabilize. Every arboreal removed weakens a complex chain of events that sustain existence far beyond the woodland borders. Some woodland arboreal release cooling particulates into the heavens. Certain kinds emit tiny organic particles that drift upward from their foliage and limbs. These particulates interact with moisture in the atmosphere, helping nebulas to form more efficiently. When radiance strikes the tops of these nebulas, it reflects back into space rather than heating the terrain. This creates a cooling effect that benefits not only the woodland, but also regions far beyond it. The arboreal perform this function naturally, adjusting their emissions according to temperature, humidity, and illumination. During the warmest parts of the day, particulate levels often rise, assisting the woodland in releasing excess heat. Over time, this process molds local weather patterns and contributes to global climate regulation. Investigators studying this phenomenon describe it as a form of atmospheric communication in which arboreal help regulate the temperature of the world. These natural particles act as tiny mirrors that soften the sun's intensity and maintain the delicate equilibrium that woodland existence depends upon. Even the shape of woodland foliage affects how Earth regulates heat. Foliage shapes vary dramatically across the woodland, from long pointed blades that shed liquid quickly to broad rounded surfaces that gather moisture. These shapes influence how radiance is absorbed or reflected. Large foliage capture warmth and release moisture through gentle evaporation, cooling the surrounding atmosphere. Narrow foliage reflect illumination differently and create subtle airflow patterns around their edges. Dripping tips guide liquid away from delicate tissues and help prevent overheating during strong radiance. When billions of foliage perform these functions together, they alter the temperature of the entire woodland and contribute to global heat regulation. The combined effect of foliage geometry, surface texture, and liquid motion creates a dynamic cooling system woven into every level of the overhead. This system helps stabilize temperatures and humidity, ensuring that countless kinds can flourish in conditions that remain remarkably consistent from period to period. The woodland becomes a living mosaic where each frond plays a part in molding Earth's climate. The loss of woodland overhead can raise terrain temperatures by more than 10 degrees. When arboreal disappear, the terrain beneath them feels the change immediately. Radiance that once filtered gently through foliage now strikes the earth with full intensity. Without shade, moisture evaporates rapidly, and the terrain heats to levels that many vegetation and fauna cannot tolerate. Studies of cleared terrain reveal that temperatures can rise by more than 10 degrees when the protective overhead is removed. This shift alters the equilibrium of the entire habitat. Kernels that once sprouted easily become dry and dormant. Bugs that required cool understory conditions relocate or perish. Small furry animals struggle to find refuge as the terrain becomes too warm for comfortable motion. Even the earth itself suffers, losing sustenance as heat and gust carry them away. The overhead acts as an insulating blanket for the woodland, safeguarding existence below. When it vanishes, the woodland loses more than shade. It loses the very conditions required to sustain its extraordinary biodiversity. Woodlands influence the flow of entire high-altitude winds across the planet. The rising columns of warm atmosphere above tropical woodlands do more than create local weather. They mold the pathways of powerful winds that circle the globe. These high-altitude currents, known as high-altitude winds, respond to shifts in heat distribution. When woodlands release moisture and regulate temperature, they create distinct patterns in atmospheric circulation. The changes in woodland cover can alter the strength, direction, and stability of these winds. Such shifts may affect the timing of tempests, the arrival of seasonal rains, and the formation of aridities in faraway regions. The woodland acts as both anchor and guide for the high-altitude winds, helping maintain equilibrium in systems that govern weather across continents. This reveals that the woodland is connected not only to tropical climates, but also to deserts, grasslands, and temperate zones. It participates in global dialogue between terrain, ocean, and heavens, influencing events thousands of miles beyond its borders. Earth in untouched woodlands can secure carbon for centuries. Beneath the dense web of radicals and fallen foliage lies Earth that has built its richness over unimaginable spans of time. Organic material decays slowly in the humid yet shaded conditions, creating a foundation that stores vast amounts of carbon. Microbes and mycelia break down vegetation matter at rates perfectly balanced by the woodland's continual input of fresh material. This slow cycling allows sustenance to remain in the earth for centuries before returning to the atmosphere. In untouched regions, the earth becomes a deep archive of stored carbon that contributes significantly to Earth's long-term climate stability. Disturbance of this earth releases carbon back into the atmosphere, accelerating warming and disrupting the primordial equilibrium. Protecting intact woodlands, therefore, protects these subterranean reservoirs that have quietly supported the planet for ages. The earth beneath the woodland is more than soil. It is a living vault molded by time, moisture, and the gentle work of countless entities. Blazes in the tropics can accelerate the melting of polar ice. When blazes burn in tropical regions, they release dark particles that rise high into the atmosphere. Gusts carry these particles across continents until they eventually settle on snow and ice in polar landscapes. The darkened surface absorbs more radiance than plain ice, causing it to warm and melt more quickly. This creates a feedback cycle in which melting exposes more terrain or liquid, which then absorbs even more heat. Although the source of the particles may be thousands of miles away, the impact reaches the farthest edges of the planet. The relationship between tropical blazes and polar melt demonstrates the interconnectedness of Earth's climate system. What occurs beneath a woodland overhead can influence the fate of distant frozen masses. This connection underscores the importance of preventing unnecessary blazes and protecting woodlands that play vital roles in moderating global temperatures. Woodlands are one of Earth's greatest climate stabilizers. They regulate heat, moisture, atmospheric chemistry, and global patterns of gust and precipitation. They hold vast stores of carbon in shafts, limbs, and earth. They cool the atmosphere through evaporation and mold weather through nebula formation. Every feature of the woodland contributes to a balanced climate. Removing these woodlands weakens Earth's ability to maintain stability. Preserving them strengthens natural resilience. Their influence spans continents and oceans, guiding downpour into parched regions and preventing tempests from spiraling into extremes. They create consistent temperatures within their own boundaries and buffer global systems against dramatic shifts. Standing within a woodland is to stand inside a vast engine of equilibrium. It is a reminder that stability comes from cooperation between living systems, each thread connected to countless others across the planet. Arboreal radicals in woodlands help anchor entire landscapes against erosion. Radicals extend far beneath the surface, weaving through earth like living cords. They bind loose particles together, preventing downpour from washing the terrain into waterways. During tempests, these radicals act as stabilizing anchors that hold slopes in place and protect waterway banks from collapse. The network of radicals also directs liquid through the earth in slow, steady channels that reduce inundation and maintain groundwater. When woodlands disappear, this natural support system collapses, causing landslides, muddy waterways, and degraded dwellings. In untouched woodlands, the radicals contribute to a complex architecture that molds the terrain itself. They create spaces for bugs, mycelia, and small furry animals to live. They assist the slow release of sustenance that feeds the next generation of vegetation. The scenery remains firm and resilient because the radicals hold it together like a foundation made of living strength. Indigenous knowledge of woodlands includes cures modern science has not yet explained. Across woodlands around the world, indigenous healers have developed remedies through generations of careful observation and spiritual connection to the terrain. Their knowledge grows from listening to the woodland's rhythms, watching how fauna interact with vegetation, and learning through stories passed carefully from teacher to student. Some treatments use combinations of foliage, radicals, produce, and arboreal rind prepared in ways that concentrate healing properties. These medicines can reduce fever, soothe discomfort, calm the mind, or bring clarity to the senses. Many have been shared with researchers who continue to study their chemical composition. Yet, science still struggles to understand how certain mixtures work. Some remedies require preparation only during specific lunar cycles or periods because their potency changes with shifts in downpour, temperature, or even radiance. To the healers, these details are not mysteries, but parts of a relationship between people and woodland that has endured for centuries. Their knowledge is a vast library written in aroma, taste, texture, and memory. And much of it remains known only within the communities that protect it. Entire tribes have lived in the woodland without ever being detected. Deep within remote regions, there are communities who have chosen to remain separate from outside contact. They navigate the woodland with an ease that comes from lifelong familiarity, moving through arboreal and waterways with silent confidence. Their homes blend into the scenery so well that even trained explorers passing nearby may never realize they are close. These tribes hunt with tools crafted from local materials, fish in hidden streams, and cultivate small gardens in sunlit clearings. Their knowledge of the woodland is intimate and expansive. They know the periods of fruit-bearing arboreal, the signs left by migrating fauna, and the patterns of downpour that mold their movements. Many outsiders learn of these groups only through brief glimpses or traces found along riverbanks. Yet these communities often flourish in harmony with the environment, guided by traditions older than recorded history. Their existence reminds the world that even in the modern age, vast regions remain untouched by outside influence, and entire cultures continue to live in ways molded entirely by the woodland. Some woodland trails are older than the cities of Europe. Long before large civilizations formed stone streets or towering buildings, woodland dwellers created pathways through dense vegetation. These trails followed the movements of fauna, the flow of waterways, and the fruiting cycles of arboreal. Over centuries, the trails became established routes used for trade, periodic migration, and spiritual journeys. Layers of footsteps packed the earth into firm, quiet paths that still exist today. Some follow ridges molded by ancient geological processes. Others wind towards sacred groves, waterfalls, or hidden valleys known only to local communities. In many places, the woodland has grown over sections of these paths, yet the underlying structure remains intact. Researchers have traced certain routes that predate many major human cities by thousands of years. Walking these trails is like stepping into a timeline that stretches far beyond written records. They serve as natural highways through the jungle, guiding both humans and fauna through landscapes molded by time, memory, and the enduring presence of the woodland. There are arboreal considered sacred and never touched by human hands. Within many woodland cultures, certain arboreal hold deep spiritual significance. Some are believed to house protective spirits. Others are seen as ancestral guardians that watch over the terrain. These arboreal often stand taller or older than those surrounding them, their radicals spreading wide and deep into ancient earth. Communities approach them with reverence, offering prayers, melodies, or small gifts placed at their base. No one climbs them, harvests their foliage, or cuts their rind. These arboreal are allowed to live their full natural lifespan, growing without interference. Avians nest within their limbs. Aerial flora form delicate gardens on their shafts. Fauna repose in their shade during the heat of the day. Even when limbs fall, the timber is left where it lands. Such arboreal become living monuments to respect and connection between people and woodland. Their presence embodies a relationship in which nature is not merely a resource but a partner, teacher, and elder. Woodland peoples use vegetation that mimic fauna summons to hunt. In certain regions, hunters carry foliage or stems that produce specific sounds when blown, rubbed, or tapped. These vegetation create tones that resemble the summons of avians, amphibians, or small furry animals. By imitating these sounds, hunters attract curious fauna or calm them long enough to approach quietly. The technique requires careful practice because each kind responds to unique patterns of cadence and pitch. Some vegetation imitate alarm summons that cause fauna to pause in confusion. Others mimic the soft notes of companionship or pairing. The hunters must understand not only the vegetation's sound, but also the behavior and mood of the target kind. This method reflects a deep understanding of the woodland's acoustic language, where every being communicates through subtle tones. The vegetation used for these summons become tools that bridge human skill with natural resonance. This practice highlights the creativity and adaptability of woodland cultures whose survival depends on attunement to the environment. Some woodland languages contain words for avians no investigator has ever documented. Within remote communities, people often name kinds long before researchers discover them. Many woodland languages include terms that describe avians known only through local experience. These words carry information about the avian's behavior, its preferred dwelling, its melody, and even the period when it appears. Some names distinguish between subtle variations in plumage or flight patterns that researchers have not yet recorded. When linguists gather vocabulary lists, they sometimes find references to avians that have never been captured in photographs or scientific surveys. These names reveal relationships built over generations of careful observation. They show that the woodland has many residents still hidden from formal study. The languages serve as living maps of biodiversity, preserving knowledge of kinds that may be rare, shy, or active only during certain hours. This linguistic richness adds depth to the understanding of culture and ecology, reminding us that science and tradition both hold pieces of the world's story. Forest dwellers can identify hundreds of vegetation by aroma alone. In many woodland cultures, children learn from an early age to recognize vegetation through scent. They inhale gently to detect the sharp aroma of medicinal foliage, the earthy fragrance of edible radicals, or the faint sweetness of blossoms that attract specific fertilizing agents. Over time, they develop a finely tuned sense of smell, capable of distinguishing slight differences between closely related kinds. Some can discern whether vegetation is young or old, healthy or stressed, based solely on the aroma carried by its foliage or rind. This skill extends into the night when illumination is scarce and aroma becomes a primary guide. The woodland becomes a library of fragrances that reveal location, period, weather, and opportunity. This sensory knowledge allows forest dwellers to forage safely, prepare remedies with accuracy, and navigate landscapes often too dense to rely on sight alone. Their ability demonstrates the remarkable adaptability of human perception when molded by existence within the woodland. Ceremonial pigments in woodland cultures come from beings that can be lethal if mishandled. Certain bugs, amphibians, or larvae produce powerful compounds that tribes use to create vibrant colors for rituals, body art, and sacred objects. These beings often secrete venoms as a natural defense against hunters. When handled with respect and skill, their secretions can be transformed into brilliant reds, deep blues, or luminous yellows. The process requires careful knowledge passed through specific family lines. Gatherers may know the exact time of year when the beings yield the safest and strongest pigments. They understand how to combine the material with vegetation extracts to neutralize harmful effects. The resulting pigments hold cultural meaning tied to spiritual protection, identity, or celebration. Their creation reflects both reverence for the beings and an understanding of the delicate equilibrium between danger and beauty. To outsiders, these pigments seem miraculous. To the communities who make them, they are expressions of connection to powerful entities who share the woodland. Some traditional woodland medicines are made using radiance, resin, and silence. In certain healing traditions, remedies are created with deliberate calm and ceremony. The healer collects fresh resin from specific arboreal at daybreak when its properties are believed to be strongest. The resin is placed in bowls of carved timber that absorb subtle qualities from the material. The mixture is then set in filtered radiance for a precise amount of time. Some medicines require the complete absence of speech during preparation because sound is thought to disturb their formation. Others require soft humming that aligns the healer with the woodland's energy. The final remedy may be applied to the epidermis, sipped slowly, or used as a compress warmed over gentle fire. Modern analysis sometimes reveals complex chemical interactions that occur when resin meets illumination. Yet the traditional method remains rooted in respect for timing, intention, and atmosphere. These medicines are as much spiritual expressions as they are physical treatments. Generations have mapped the woodland not with paper, but with memory and melody. Before written maps existed, woodland communities navigated through stories sung across generations. These melodies often describe the shapes of mountains, the bends of waterways, the summons of avians that marked certain locations, and the presence of sacred groves hidden within the dense overhead. The children learned the scenery through cadence, tune, and repetition until the woodland became a mental map woven with sound. Paths were remembered through verses describing the taste of specific produce found along the way or the sound of liquid at particular bends. Even subtle differences in gust or earth were encoded in the melodies. Travelers relied on these musical maps to cross great distances, carrying knowledge that adapted with each generation as the woodland changed. These melody maps reflect deep intimacy between people and place, showing that geography can be preserved not only through lines on paper, but also through memory molded by voice and breath. Some woodland bugs can alter the weather by releasing particulates. Within the woodland overhead live bugs that contribute to atmospheric processes in subtle yet powerful ways. As they feed, move, and release natural chemicals into the atmosphere, they emit microscopic particles that serve as seeds around which moisture can gather. These particulates drift upward through warm atmosphere currents created by the woodland itself. When they reach cooler layers of the atmosphere, vapor condenses upon them and forms nebulas. Over time, these nebulas may grow dense enough to release precipitation that falls back onto the woodland. In this way, even the smallest beings influence the liquid cycles that sustain the habitat. Their activities add texture and complexity to the woodland's respiration, blending with the emissions of vegetation, mycelia, and earth microbes. Bugs play an active role in molding conditions that affect their own survival, demonstrating that weather is not solely the product of gust and sun, but also the combined actions of countless living beings. The woodland heavens become a living reflection of activity occurring at ground level. Arboreal radicals can send chemical warnings to other arboreal miles away. Beneath the woodland base stretches a vast network of interconnected radicals woven together through earth, mycelia, and moisture. When one arboreal experiences stress due to nuisances, aridity, or injury, it releases chemical signals into this network. These signals travel along radical pathways and mycelial threads until they reach other arboreal. Upon receiving the message, neighboring arboreal begin to alter their internal chemistry by producing protective compounds or adjusting their liquid use. Some even change the structure of their foliage to reduce vulnerability. This communication can extend across great distances because the underground web links entire sections of the woodland. The process occurs silently, without any visible sign on the surface. Yet it demonstrates a hidden cooperation within the habitat. Arboreal behave not as isolated individuals, but as members of a community that shares information essential for survival. Their warnings reveal a sophisticated awareness of danger and an ability to respond as a unified presence. Certain arboreal hum high-frequency vibrations to signal stress. Deep inside their shafts, arboreal contain networks of vessels that move liquid from radicals to foliage. When an arboreal experiences aridity or damage, the tension within these vessels changes. These shifts create vibrations that travel through the timber as sound waves too high for human ears to detect. Sensitive instruments reveal that stressed arboreal emit continuous high-frequency hums that differ from the sounds of healthy ones. Other entities, including bugs or furry animals with acute hearing, may detect these vibrations and respond accordingly. Some nuisances are drawn to the hum while others avoid it. The woodland becomes a quiet orchestra of signals that reflect the changing conditions of its members. Although humans cannot hear this communication, it forms an integral part of the woodland's hidden dialogue. Each hum marks a moment in which the arboreal reaches outward into the domain, expressing its need through the language of vibration. There are creepers that move towards sound vibrations in the overhead. Certain climbing vegetation exhibit sensitivity to vibrations in their surroundings. As fauna move through the overhead or as gust shifts limbs, distinct patterns of motion ripple through the atmosphere and through the timber of nearby arboreal. These vibrations help guide the growth of creepers. Instead of growing randomly, the creepers slowly adjust their direction, bending toward the source of consistent vibration. This allows them to locate sturdy shafts that offer reliable support for climbing. The process unfolds gradually with each new growth tip responding to the faint messages carried by sound. This behavior reveals a surprising sensory capacity within vegetation, showing that they interact with their environment through more than illumination and chemical cues. The motion of a creeper toward vibration demonstrates the responsiveness of woodland vegetation to the dynamic activity of fauna, weather, and neighboring arboreal. It is a quiet pursuit that transforms the overhead into a web of intertwined lives. Woodlands produce aromas that travel across oceans on the gust. Every frond, blossom, and produce within the woodland emits natural compounds that rise into the atmosphere. These aromas combine into a complex signature unique to each region. Once airborne, the molecules enter vast atmospheric currents that carry them far beyond the boundaries of the woodland. Over days or weeks, the aromas drift across islands, coastlines, and entire oceans. In some cases, these airborne chemicals seed nebula formation or influence downpour patterns in distant lands. They also bring hints of the woodland's presence to places that may never see its arboreal. Certain compounds break down as they travel, while others remain intact, continuing their journey across the globe. The woodland becomes part of a planetary cycle of aroma in which the chemistry of one region influences the atmosphere of another. These fragrances reveal that woodlands broadcast their identity through the heavens, participating in interactions that span continents. Some foliage turn away from the sun when danger approaches. In moments of threat, certain vegetation respond to subtle cues in their environment by adjusting the angle of their foliage. When bugs begin to gather or when nearby vegetation release signals of stress, these foliage rotate slightly or fold inward. This reduces exposure to herbivores and makes the vegetation less vulnerable to damage. The motion may also limit evaporation, allowing the vegetation to conserve liquid in times of distress. These changes occur through shifts in internal pressure within specialized cells that act like tiny hinges. The woodland is filled with such movements during moments of tension. Although invisible from afar, they reveal a domain in which even quiet vegetation respond quickly to information around them. Their ability to sense danger and act upon it demonstrates a level of awareness rooted in evolution. Each foliage motion shows the woodland's ability to protect itself in ways both subtle and profound. Certain woodland vegetation use magnetic fields to orient their growth. Within their cells, some vegetation possess structures that respond to the magnetic forces of the earth. These structures help guide growth toward favorable directions, ensuring that radicals spread efficiently into the earth while stems rise toward stable illumination. Magnetic awareness allows the vegetation to maintain consistent orientation even when gust, precipitation, or overhead shifts alter the visual cues within the woodland. This capacity becomes especially valuable in dense environments where radiance arrives in scattered fragments rather than clear beams. Vegetation with this sensitivity grow in a manner that maximizes stability and efficiency. Researchers studying this phenomenon believe it may help certain kinds survive in challenging conditions where other forms of navigation are unreliable. The woodland contains countless examples of complex behavior hidden within the biology of its vegetation, and magnetic sensitivity is one of the most remarkable of these subtle adaptations. Illumination filters through woodland mist in patterns unique to each location. When radiance enters the woodland at a particular angle, it encounters moisture suspended in the atmosphere. This mist scatters the illumination into rays that drift across foliage, creepers, and limbs. The patterns formed depend on the composition of the atmosphere, the density of the overhead, the temperature of the morning, and the altitude of the terrain. No two places create identical displays. In some regions, beams of warm gold spill down like tapestries touched by motion. In others, cool white ribbons form delicate columns that illuminate floating pollen. These patterns change moment to moment as gust alters the mist and as arboreals sway with gentle pulses of atmosphere. Fauna respond to these shifting lights by adjusting their activity. Avians begin foraging when the first rays brighten their perch. Bugs rise into beams that warm their wings. The woodland becomes a sanctuary of moving illumination, molded by the unique conditions of each location. Some entities in the woodland have never been photographed alive. There are kinds so rare, so elusive, or so remote that investigators know of their existence only through traces such as shed epidermis, footprints, or brief glimpses recorded decades ago. Some appear in local stories, but remain absent from scientific documentation. Others are known from museum specimens collected long before cameras became common. These entities navigate hidden regions of the woodland where human presence is rare. They may live high within the overhead or deep within labyrinths of radicals. Their avoidance of detection reflects both their rarity and the density of the woodland, where shadows and layers conceal even large beings. Researchers continue to search for them using sound recorders, aroma traps, and infrared equipment. Each attempt reflects the hope of glimpsing beings that have remained private for generations. The woodland still holds mysteries that defy our expectation that everything can be seen or measured. There may be kinds in the woodland whose existence we still cannot imagine. The woodland contains so many micro-dwellings, so many layers of earth, foliage, liquid, and atmosphere that entire lineages may remain hidden from science. Some could dwell in overhead zones rarely reached by humans. Others might flourish within earth structures or rotting logs where illumination never enters. There may be entities with behaviors, shapes, or life cycles beyond anything currently known. Each expedition into unexplored regions reveals new forms of mycelia, bugs, or tiny vertebrates that reshape our understanding of biodiversity. These discoveries hint at a deeper truth. For every kind described, many more remain undetected. The woodland is not a completed catalog, but an unfolding realm of possibilities. Within its depths lie beings whose existence challenges imagination. Their discovery may expand our view of what existence can be. Until then, they remain part of the woodland's quiet mystery. As the last echoes of distant avians fade and the woodland settles into its soft night cadence, let your thoughts settle with it. You have wandered through a domain molded by mist and radicals, by beings seen and unseen, by primordial stories written in foliage and flowing liquid. Let that sense of wonder stay with you as you repose. A gentle reminder that there are still places on Earth where mystery respire in every direction. If these peaceful explorations appeal to you, feel free to hit like, subscribe, or drop a comment in the section below. Your presence helps fellow viewers discover this space, one peaceful wanderer after another. You are always welcome to return, whether to explore new domains or simply to repose in the quiet company of stories. But for now, allow your respiration to slow, let your frame grow heavy, and let the gentle cadence of the woodland carry you to slumber. Good night.